Good day. Today, we're gonna talk about fundamentals of deformable bodies, and our topic is normal stress and shear stress. But before that, let's know about normal stress and shear stress. Let's get on to the video. Oh, and before that, let me introduce myself. I am Randy D. Ganapin from BSEE2B. Let's go. Normal stress. A normal stress is a stress that occurs when a member is loaded by an actual force, and the shear stress is a force tending to cause deformation of a material by slippage along a plane or planes parallel to the imposed stress. So, this is normal stress and this is shear stress. In normal stress, there are two types, the tensile stress and the compressive stress. In tensile stress, the two force is stretching the object. So, what will happen to the object? The object will become thin. And this is the formula for the normal stress. It is called normal stress because the force is perpendicular to the area. Force acting in the tensile stress is called tension force. So, next is the compressive stress. In compressive stress, the force acting in the object is compressing the object. So, the object will expand. And it will form like this because the force is compressing the object, and the force acting in this compressive stress is called compressive force. In shear stress, the force is parallel to each other, and this force is called the tangential force, and this is the formula for the shear stress: F over area, force over area. So now, what will happen to the shear stress? It will, or the object, it will form like this. It will form into the shape of a parallelogram because their force acting on the object is parallel. So now, we will going to answer a sample problem. The problem is, for the given state of stress, determine the normal and shearing stress exerted on the oblique face of the shaded triangular element shown. Use a method of analysis based on the equilibrium of that element, as was done in the derivations of section 7.2. So what I did in this solution is I divided the triangles into three so that I can find the stresses, the areas, and the forces. So this is the result. This is the original from the sample question. So this is the shaded part. Now let's go to the real solution. So this is what I did in the solution. So this is what I recently find out a shortcut. So what I did is this: normal stress times A minus 84A cosine 55 degrees times cosine 55 degrees. These two is from the forces, the 84A cosine 55 degrees and the 42A sine 55 degrees. So this is what happened. I first transpose, so the negative 84 and the positive 42 became like this. I transposed and eliminate the A. I divided the A from both sides. So remaining is the symbol for normal stress is equals to 84 cosine squared 55 degrees minus 42 sine squared 55 degrees. Cosine squared 55 degrees is because cosine times cosine is cosine squared and 55 degrees. Then sine times sine is sine squared 55 degrees. So this is the answer. Negative 0.547 millipascal. This is our normal stress. So next, we're going to find out the shear stress. So the same with the normal stress, but with a twist. So normal stress times area minus 84a cosine 55 times sine 55 degrees. So from cosine 55, it became sine 55 minus 42a sine 55 degrees cosine 55 degrees. And transpose, eliminate the a, and this is the result. Shear stress, or this symbol, is equals to 126 cosine 55 degrees. Why 126? Because if transpose, this negative becomes positive and this negative 42 will become positive. So positive 84 plus 42 is positive 126. Cosine 55 degrees and sine 55 degrees because I combined them both. So the answer is 59.201 millipascal. So that's it for this video. Simple, right? And thanks for watching.